Hi, I'm going to do one more graphing problem for you. Negative log base 5 of negative x. Now you're probably looking at this and thinking to yourself, I don't even know where to start something like this. This is just crazy. But just go back to the basics. And a function that is a little bit more basic than negative log base 5 of negative x, but still related to it, is log base 5 of x. Okay? So I'm going to graph that one. Now, again, we still don't quite know how to, it's kind of hard to visualize the idea of a logarithm, and it's kind of hard to plot those points because you almost have to think backwards to do it. So instead of logarithm, I will find the inverse of the log base 5, which happens to be 5 to the x, and I'm going to make a table using that, because if I make a table using that, then remember that since these are inverses, the domain of one is going to be the range of the other. So I always use the points 0, 1, and negative 1 just for fun. So 5 to the negative 1 is 1/5, 5 to the 0 is 1, and 5 to the 1 is 5. So that's the table for 5 to the x. Now the inverse of that, log base 5 of x, is just reverse everything. So it's going to be 1/5 negative 1, and then it's going to be 1, 0, and lastly it's going to be 5, 1. Okay, so now we've got the table for log base 5. Let's put that on there, and let's use a really light color when we do that, because we really don't want that to distract us from the final goal here. So 1/5 negative 1, and 1, 0, and 1, 2, 3, 4, 5, 1. And remember that just like exponential functions have a horizontal asymptote, logarithms have a vertical asymptote. Okay, so I draw my curve here. And again, I know it's hard to see, but we really don't want to focus on it too much because it's just a temporary stop until we get to the final answer. Now the final answer is, I've actually got two things happening here. If you're really good, you might be able to do both things at once. A negative in front of the logarithm flips the logarithm like this. Okay, so it looks like I'm sharpening a pencil here. See, so negative in front of logarithm, that's like sharpening the pencil. And then a negative on the inside here, that flips a graph this way when it's right in front of x. So, I'm flipping a graph this way. That's kind of like screwing in a light bulb. See, I'm trying to do like the Karate Kid method of teaching you math. So instead of telling you to reflect about the x-axis, if you see a negative in front of logarithm, I say, sharpen the pencil. And then instead of telling you to reflect across the y-axis, when there's a negative in front of x, I say, change the light bulb. So it's kind of like the Karate Kid, how he was always like telling you to paint the house, wax the car, and scrape the floor, and then like put on the coat and take off the coat. And really he was teaching them karate or kung fu, but actually the kid thought he was crazy. So anyhow, that's what I'm doing. So now I am going to take my original graph and I'm going to sharpen the pencil and screw the light bulb. So to sharpen the pencil, this point doesn't move, but this point flips down and this point flips up. Really it doesn't matter which one you do first. And again, I'm using, let me use even a lighter color than this because I don't want you to be distracted by a temporary step. So this is a temporary step on our way to the final graph. Whoa, that looked ugly. Okay, so there is a flip across the x-axis. I think I said y once, but that's across the x-axis because of this negative. That's what caused that flip. And then my final answer, this negative here is going to cause this point to flip here, and this point to flip here, and this point is going to go 1, 2, 3, 4, 5 in the other direction. The vertical asymptote didn't move this time for this problem like it did for the last one. But anyhow, that's your final graph. Looks really nice. Didn't teach you karate, but taught you how to graph a logarithm, probably almost as good, right? So you may not be able to break a log with karate, but you can graph a log, right? Yeah.